So for this second part of 7.2, we're going to be doing a little more simplifying, and then we're also going to be adding and subtracting some radicals. Okay, so going back to simplifying with no decimals. Now, there's going to be times when you're going to have some radicals that are going to be multiplied together. So let's say I give you the cube root of 5x to the 8th y squared times the cube root of 4x to the 6th y. Now, since they both are cube roots, we can multiply what's inside the radicals. So we can rewrite this as the cube root of 20x to the 14th y cubed. Now, some people might want to simplify these first. I know you can simplify the x to the 8th when it's in that cube root. My suggestion is multiply first, simplify second. Okay? If you simplify first, you might, after you multiply, you might have to do more work to simplify it again. My suggestion is multiply it once, simplify it once. Okay? Because now if I'm looking at the cube root of 20x to the 14th y cubed, I might only have to simplify one time. Cube root of 20 you can't do anything with. No factor tree, doesn't work out nice. 3 goes into 14 4 times with 2 remainders, so x squared on the inside. And 3 goes into 3 once, so I'm just going to have that y on the outside. And there's your answer for that one. Okay? Same work as if it was square roots. So we have the square root of 3, x to the 7th, y to the 8th. Let's do square root of 6, x cubed, y cubed. Okay, so again, I know you can simplify a little bit. Now, I'm going to do my multiplying first. Square root of 18, x to the 10th, y to the 11th. Okay, so look at square root of 18. You can do a factor tree for that. You can do a factor tree with square roots this time. You need to make sure you're keeping your square roots and cube roots straight. So we have the square root of 9 goes to 3, square root of 2. 2 goes into 10 5 times, no remainder, so no x on the inside. 2 goes into 11 5 times with 1 remainder left over. And there's your answer for that example. Okay? So when you're multiplying through, multiply first and you simplify just like we have before. Okay? So make sure that you're thinking of factor trees. How do you simplify it? And if you can't do a factor or anything, you just leave it on the inside. Don't try and force anything to happen. There's times when you won't be able to do factor trees. There's times when things won't be able to be simplified at all. Okay? We hope it works out nice. We hope that it works out perfectly, but it's not always going to happen. Right? So that was simplifying. Now we're looking at adding and subtracting. You add and subtract radicals just like if they were like terms. You are going to combine the like terms. So if you were given something as 3 plus 2 square root of 5 plus 8 plus 5 square root of 5. Okay? Well, the like terms, the 3 and the 8 are like terms. Both the integers, you can add them together. Just watch your signs, you get 11. And now 2 square root of 5 plus 5 square root of 5. That square root of 5 is treated just like a variable as x. Okay? You have, just like if you were doing variables, you need to have the same variable and the same exponent. Here you need the same index and the same radicand. And if you have the same index and the same radicand, you can add those coefficients together. 2 square root of 5, 5 square root of 5, 2 plus 5 is 7. And that square root of 5 stays the way it is. Okay, just like x stays an x when you combine like terms, you're doing the same thing here. Leave that square root of 5 as a square root of 5. Now, for this, everything was already as simplified as it could be. Okay, we look at one of my examples here. Sometimes you're going to have to do more work. Let's say 3 square root 20 plus square root of 45 plus 5 square root of 5. Now in this case, at first look you'd say I can't combine anything. We have square root of 20, square root of 45, square root of 5. Those can't be combined. But square root of 20, square root of 45, they're not simplified all the way. You can do factor trees for those and simplify them a little bit. Factor tree for 20 goes to square root 4 and square root 5, and the 4 goes to 2. Now, since it has a coefficient, don't forget to multiply those together. 2 times 3 is 6 square root of 5. For 45, we have 9 and 5. The 9 goes to a 3, so it's plus 3 square root of 5. And the 5 square root of 5, we're just going to bring down. There's nothing to simplify there. But now looking at this, now we have square root of 5, square root of 5, square root of 5. Now they're considered like terms, and now I can combine them together. 6 plus 3 plus 5, just watch your signs when you're doing this. This should give you 14 square root of 5. And there's the answer for that one. All right, let's do one more of those. Let's do square root 12 plus 3 square root 27 plus 5 square root 2 plus 3 square root of 32. So again, looking at it, none of the radicals look nice right now, but we can do a factor tree for almost all of them. Okay, so factor tree for 12, and I'll go through this a little faster, should be 2 square root of 3. Factor tree for 27 is 3 square root of 3. Do not forget to multiply that coefficient. That's probably the most common mistake, is just bring down to 3 square root of 3. Since there's already 3 out there, you need to multiply those coefficients. 9 square root of 3. I'm just going to bring down my 5 square root of 2. And the square root of 32, we're going to have 4 square root of 2. Again, don't forget to multiply. 12 square root of 2. Now we have some things we can combine. The 2 and the 9 both have square roots of 3, so that's going to be 11 square root 3 plus the 5 and the 12, 17 square root of 2. Okay? So make sure everything's as simplified as possible before you start combining like terms. Okay? And if you can do a factor tree, you have to do it. If you can simplify, you need to simplify. Okay? So that's going to be the second part of 7.2.